Hey guys, it's Athena, and I'm here to show you how to find bases for column space and null space of any given matrix A. So here I have my matrix A, which was given to me, and I'm going to go ahead and row reduce it, since we can't actually do anything with it in this form. And when we row reduce, we turn it into something called echelon form. So this is what it looks like in echelon form. I did mine in decimals. If your professor prefers fractions, do it in fractions. But since it was not specified for me, I did decimals since that's what I like better. So you'll notice here that we have a stair step of ones with zeros under them. These ones are called pivots, and the columns, which these ones are in, are called pivot columns. We're going to go ahead and take these columns 1, 2, and 3, and go back to our original matrix to find our basis. So basis of ColA, which means column space of A, ColA is how it's denotated, is columns 1, 2, and 3 of A. And then you put your nifty little comma in between them so your grader, your professor, doesn't think you're multiplying them. Now we're switching over to null space. So to find the basis for the null space of A, it's a little different than column space. We don't actually go back to our A matrix. We go back to the echelon form of the A matrix. So I've recopied it, and then we're going to perform row reduction again. But before we do that, we're finding null space. So that means we're setting our A times X equal to 0, which means we have to do something called augmentation. And augmentation is just adding a column of zeros to the rightmost side of your matrix. So there's my new matrix, and I've added my zeros right here. So now that I have the right kind of matrix, I can row reduce. And since we're row reducing the echelon form, the new matrix that we come up with is going to be called the reduced echelon form, as you can probably guess. So there's my new matrix. And what we're going to do is find x1, 2, and 3 in terms of x4. Since x4 is a bunch of zeros, it's a free variable. So we're going to go a little something like this. x1 times 1, x2 times 0, x3 times negative 1.25, and since we're writing everything in terms of x4, we are not going to include this column at all in the calculations. So we add them all together, and then we solve for x1 since it was our lone variable. And that's how we calculate our x's. So it's going to look a little something like this. I went ahead and did this just to show you, and see we have our x1 times 1, x2 doesn't exist in this equation, and then since it's plus a negative, I went ahead and did minus 1.25 times x4, since x4 was our free variable, since it was this column of zeros. And since we set that equal to 0, we solve for x1, move the 1.25 x4 over, and we have x1 equals 1.25 x4. And we went ahead and did that for x2 and x3. And so now we have what our x1, x2, x3 equals. And then of course x4 would just equal 1 because x4 is equal to x4. So to find the basis of null A is how we denotate null space of A. We're going to go ahead and put it in parametric vector notation, which means we are going to take our x's and we're going to put them in their own matrices. My subscripts are gone, but x1, x2, x3, x4 are the same here as they are right here. And we're going to pull the numbers out of our calculations that we did right here. So 1.25, 1.00, and 1.75, and put them parallel to x1, x2, x3, and then of course just set x4 equal to 1 because x4 is equal to x4. So this is what that's going to look like. And it's not notated here, and that is my mistake because it should be, but there should be an x4 right here in front since all of the variables here are multiplied by x4. There should be an x4 out here in front of this matrices. But that's how you do column space and null space. I hope my little tutorial here has cleared up any confusion there was in doing equations for column space and null space.